All right, so in the video for our retake assignment for Chapter 10B, I'm going to go through the answers to these questions, check your rounding, check your process, check the work that you showed when you filled it out the first time, and see where you went wrong, if you went wrong. So the first couple problems, the first two, are the special type of triangle where you don't know what the height is. So since I don't know how tall this triangle is, I can't use the 1/2 base times height formula. Instead, I need to use the formula I have written down at the right, 1/2 BC times sine of A. So the B and the C are the side lengths. So 15 and 19, either order, either one could be B or C. And then A is the angle that's in between. So when you have side, angle, and side on a triangle, you can always get the area this way. And this is a nice way of finding the regular polygon problems when they give you the radius, which we'll get to. So all we have to do is go to the calculator for this. We set up here, we have 1/2 times either 15 or 19, either order, and then times the sine of 45. So we have 1/2 times 19 times 15, 1.5 times 19 times 15 times the sine of 45. Oops, not 456. So that comes out to 100.76. Again, one of the reasons you could have things wrong in your first attempt is rounding. This one says nearest tenth, so we are going to round this one up to 100.8. Second one is the same exact setup, so we just need to back up to our plug-in step and then go back to the calculator. So B and C are 12. They're both 12 in either order. So I have 1/2 times 12 times 12 times sine of, this time it is 78. Calculator. 1/2 times 12 times 12. Oops, 12 times 12 times sine of 78. That's going to give us 70.42, or 70.43, I guess is the proper way to round that. But nearest tenth, that's going to round down to 70.4. They don't have us putting in the units, or the units are already attached at the end here. We'd be in square meters. So this one's 70.4. All right, this one says, find the area of a regular decagon with radius 5 feet. So I'm going to use the same formula for part of it. Remember that for the area of a triangle, a regular decagon or a regular polygon, is that 1/2 ASN. But if they give you a radius, so here's my decagon. Okay, I know it's not really going to have 10 sides, but that's okay. If I know that the radius is 5 feet, that's this distance here. So if this is 5, this is 5. So what I can do is I can get the area of just that triangle and then multiply by how many triangles there would be, which is 10 this time since it's a decagon. So what I'm going to do is I'm going to use this same formula and then I'm going to multiply it by 10 because that's how many sides there are. That's how many triangles there will be. So really all that we need to do, if they give you a radius, all we need to do is say, well, whatever that radius is, that's what B and C is. Okay, the sine of A, that's probably the tricky part here. Okay, and then we're going to multiply by 10 in just a second. So to figure out what this angle is, think about the triangle that we're looking at. We have 5, we have 5. We got to get this angle. Okay, the way we do that is we take 360 divided by how many sides we have. So that would be 10, or we have 36 degrees for what A would be. So I'm going to go back to the calculator, change these to 5s, 1/2 times 5 times 5, and then times the sine of 36. And then when we multiply that by 10, what did I do wrong? Maybe I need parentheses here. Yeah, okay. So now what we have here, 0.5 times 5 times 5 times sine of theta. Yeah, perfect. So that comes out to 73.47. I think we're still doing nearest 10th. Yes, we are. So that would round up to 73.5. So let's back up so we can go and punch everything in here. So they're going to give you a little hint that we should have done the BC formula instead of the ASN formula like next time. But B and C should be the same thing, 5 and 5. A, the angle we got was 36. N was how many sides there was, which is 10. And then our final answer to the nearest 10th, 73.5. So that's if they give you a radius. We do it this kind of new way. If they give you the apothem or a side length, we're going to go back to the ASN formula that we had done previously in the first part of the chapter, 10a. So they gave us what A is, so I'm going to type that one in right away. The rest of it we got to try to figure out. So I'm going to get rid of this because that's not going to be the way we want to do this anymore. So we're going to do the 1/2 ASN formula. We know that A is 8. We don't know S. We know that N, since we have a pentagon, is 5. So let me put that one in too. So we got to figure out the side length. And then once we know the side length, we know this formula gives us this answer. So what we showed you this half of the chapter was how to use trig to figure this out. So again, we could draw the whole pentagon. I'm just going to draw one triangle. They gave us the apothem, which is the height of the triangle, and that is 8, given to be 8. Okay, what we need to be able to do is figure out the side length. I'm going to put an X right here. The side length is the entire bottom, so I can find this piece with trig, with SOHCAHTOA, and then I can double it to get the side length. So we'll come back to that idea in a second. I need to get this angle, similar to the way we did that last time. We do 360 divided by how many sides there are, and we get 72. The thing is, just like the 8, the apothem is cutting the bottom side in half, it's also cutting this 72 in half. So I need to divide that by 2 and put a 36 up there for my angle. Okay, so then we think about our SOHCAHTOA. So we have X, the side we're going to get, is the opposite side. 8, the side we know, is the adjacent side. If I know O and A in a right triangle, that's TOA, so I use tangent of 36 equal to opposite, which is X, over adjacent, which is 8. Since the 8's on the bottom, I can multiply both sides by 8, and then that's going to be what goes in the calculator here shortly. Okay, so that's going to be close to what the side length is. Remember, this is only going to be half of the side length. So let me go to the calculator for where we're at. We have 8 tangent of 36. Whoa, tangent of 36. Okay, that 5.81 is equal to X, but what I need is S, which is 2 of those 5.81s. So we end up, that's not right. Let's see, parentheses again, and then times 2. We have 11.62 for what our apothem is. Looks like not our apothem, our side length. They wanted us to do nearest 10th, so I would put 11.6 right here. And then we're ready to go to the formula. So we know that the formula is 1/2 times A times S, which we just found, times N. Maybe I should put, no, I'm going to leave that, times 5. Okay, so this one might be one, if your answer is really close to what I get, we might need to check it. You might have it right, but there's a couple different ways you could round and get some things messed up here. So check with me if you think your answer is really close to this, but you're not getting credit. So 1/2 times 8 times 11.62 times 5. 1/2 ASN. So we get 232.4 square units, whatever the units were. 232.4. Good. So that gets us through the regular polygon differences here. If they give you a radius, we're going to use this formula, the triangle formula. If they give us an apothem, or this one's apothem again, or if they give us a side length, if they would have given us S instead, then that would have been the same thing. Okay, so let's go to number 5. Number 5, they give us a radius again. Oh, I'm sorry, an apothem again. So it's going to be very, very close to the same steps here. Okay, we have 1/2 ASN. We know that A is 6. We don't know S. We know that N is also 6 because it's a hexagon. So when we look to get S, again, the first thing we're going to do is find X, and then we're going to double it to get S. We know that we have a 6 that goes here, the apothem. 360 divided by 6 gives us 60, but we need to divide that by 2 because the apothem is going to cut that in half. So we're using 30 this time. Okay. So for this one, we could use 30, 60, 90 triangle rules, but just to keep the steps simple here, or repeating at least, we're going to do trig again. So we have opposite and adjacent again. It's going to pretty much work out to be tangent on these. So we have tangent of 30. We set that equal to opposite, which is x, over 6, which is a. So 6 times the tangent of 30 will give us half of what the side length is. So if we do 6 times the tangent of 30, we end up with 3.46, but we're going to double that right away and get 6.93 equal to S. Okay, so 6.93 is S. We're going to plug that in here to the formula to get our answer, and then we'll go right to the calculator with it. So we have 1/2 times A, which is 6, S, which is 6.93, N, which is also 6, and we're going to go with that. So 0.5 times 6 times 6.93 times 6 again. And it looks like we're at about 124.74. We're going to round that to the nearest tenth when we fill in our answer. So they gave us that A was 6. We found that to the nearest tenth, S was 6.9. We have 6 for N, that was given. And we have 124.7 for our answer for number 5. Okay, number 6 is back to the radius way. Since they gave us a radius of 3, we're going to use this formula, 1/2 BC sine of A, to get that area. So B is 3. That's the radius, which is the same as C. A, we're going to figure out. We know N for a heptagon is 7. So what we're going to do is we're going to do 1/2 BC sine of A. We're going to multiply by 7 because it's a heptagon. So we have 1/2, we have 3 times 3. The one thing we got to figure out is what A is, and then we're ready for the calculator. A is 360 divided by how many sides there are. So 360 divided by 7. 360 divided by 7, which is 51.43. And that's what we're going to put into the calculator in just a second. It does say nearest tenth again, so I'm going to put it in there as 51.4. And then let's get the final answer. So we have 0.5 times 3 times 3 times sine of 51.43 times 7. And that comes out to 24.63. To the nearest tenth, that's 24.6. All right, so let's change the topic here. Now we have find each measure in the circle below. Well, measure of APD, that would be this distance, A to P to D, so they want this angle right here. Remember, anything that goes through the center cuts the circle into 180 degrees and 180 degrees. So these two, 90 and 60, they make a total of 150. So this angle here has to be what makes all three of them equal to 180. So 90 plus 60 is 150. APD has to be 30 because these three numbers have to make 180 since CPB is going right through the center. Arc AC, that shouldn't be too tough either. Arc AC, well, AC on the outside is whatever this angle, these two angles add up to on the inside. If this is 30, like we just said, and this is 90, the arc A to C has to be 120. Another way to look at it, if AB is 60, these two arcs need to make 180. 180 minus 60 is also 120. All right, arc ABD. This is where people mess up. You have to go in the same order that they say. ABD, so they want all of this all the way around. So they want everything except for AD. Okay, well, we figured out that arc, we know that arc is the same as this angle. We figured out this angle is 30. So 360 would be all the way around. I want 360 minus this piece. So I want 360 minus 30, which is 330. And the measure of CPA, it's kind of like what we did with getting the measure of AC. CPA is again 90 plus 30, 120. This answer and this answer are the same because AC, the arc, is intercepted by CPA, the angle. So whatever this angle is, this has to be the same. Okay. And remember, anything less than 180 is called minor. Things that are exactly 180 is called a semicircle. Things that are more than 180 those are called major arcs. All right, so now we have a couple things that we do with these. You either find the length of the arc or you find the area of the sector. So they want how long the crust is or how big the slice of pizza is. So they want the arc length, which is a chunk of the circumference. So arc length is how many degrees out of 360 times the circumference, which is 2 pi r. Okay, so this time I'm going to put arc. So we have an arc of 110 degrees. We're multiplying that by 2 pi r. It does say to leave our answer in terms of pi. I'll show you how to do that in a second. 2 pi times the radius, which is 4. So we have 110 over 360. If I do the 2 and the 4, that makes 8. So it's times 8 pi. So 8 pi is the circumference all the way around. What we want is what's just this chunk. Well, let's go to the calculator for it. So we have 110 over 360. That's the chunk of the circle we want. We're multiplying that times 8. I'm not going to punch the pi in because I want this to be in terms of pi. So 110 over 360 times 8, that's 2.4 repeating, or 2.4. And then we're going to keep the pi in the answer. So all we need to do is type in the 2.4. Okay. The length of this red arc, okay, well, let's just back up to this piece. The amount of degrees that we want is 50. The radius of this one is 10. So we're going to take 50 over 360 and we're going to multiply that by 20. And then we're going to leave pi in the answer. So 50 over 360 times 20. That's 2.78. We'll round that up to 2.8. We're not going to put the pi in the calculator. We're going to keep that as part of the answer. So we would type in 2.8. Okay, let's keep going. One thing that's happening here that's a little bit different is they have the entire, and I think that's the first time it happened, yep. They have the entire diameter drawn in, okay, which means 3 is not the radius. It gets confusing with these arrows. If they draw the whole diameter in, then 3 is this entire length. Okay, so that means the radius is half of that, which is 1.5. But what's going to happen is we're going to double that right back to 3 in a second. I'll show you. First thing we got to do is figure out how many degrees over 360. They want this arc. Well, I don't know what that is. I know that this is 120, and I know that these two make 180. So 180 minus 120 will give me this angle, which is the same as this arc. So this one, we're going to put a 60 up top. Then we're going to do times 2 pi r. Well, r this time is 1.5. Okay, so 60 over 360, that is 1/6. If you're going to the calculator, you don't have to simplify that. We're doing 1/6 of 3 pi. So when we do 60 over 360 times 3, we're going to get basically 3 divided by 6, which is 1/2. So this is 0.5 pi. You might have been able to type in 1/2 pi. I'll check on that after this video. Again, the pi is part of the answer, so we're not going to type that in, and we're not going to punch it in the calculator. All right, one more arc length. All right, this time 3 is back to being the radius. So we just have to figure out how many degrees out of 360. This time we have 120 given again, but it's not on a semicircle this time. We have this is 120. The rest of it needs to make 360 with the whole thing. So 360 minus 120, we would put a 240 up top. We're going to multiply that 2 times pi times the radius, which is 3. 240 over 360, that's like 2/3. I'm going to leave it the same since we're going to do the calculator step next, times 6 pi. We're going to leave our answer in terms of pi, so all I need to change is this to a 240 and this to a 6. So 2/3 of 6 is 4, so this one would have an answer of 4 pi. All right, so now let's look at how this can be different. If they want the area of a sector, now it's still something out of 360, the arc out of 360, but now it's times pi r squared because that's our area for formula for the area of a circle. So the amount of degrees out of 360 for this one is 120. So we would go 120 over 360. But this time we're doing pi times r squared, which is 4 squared. So we're doing basically 1/3 of 16 times pi. So we're doing 120. Oops. We're doing 120 times 16. 120 over 360 times 16. So that's going to be 5.3 repeating. We're going to call that 5.3 and then pi. So that's how you get the area of a slice of pizza. All right, let's do another one. So the question 13, the area of the shaded sector. All right, for this one, the amount of degrees is 75. And the radius is 9. So we're doing 75 out of 360. We're multiplying that by 81. We're going to leave pi out of the calculator. And then just know that it's going to be part of our answer at the end. So we have 75 over 360. We're multiplying that by 81. We get 16.875. You should have been able to put that whole thing in the calculator. You could round that to the nearest tenth and call it 16.9 pi. Oh, I'm not reading directions now, am I? So this one, they want round your answer to the nearest tenth. So this is wrong. I need to figure out what that is times, and then that will give me 53.01, and that is just going to round right back down to 53.0. So to the nearest tenth, this is 53.0 square inches. So you got to be careful. Like I kind of messed that up. If they don't have a pi as part of the answer here, then you got to put it in if it says nearest tenth. Okay, so let's do one segment problem. Okay, with segment problems, what we do is we take the area of the sector, so segments, we take the sector minus the triangle, because there's a sector here if it was all shaded in, but there's a triangle taken out of the sector that gives us just this segment. So this is the area of the pizza crust instead of the length of it. All right, so here's how these work. The sector is how many degrees out of 360. This box means 90, so we have 90 out of 360 times pi r squared. R is 8. Minus the triangle formula we did before, 1/2 BC sine of A. So we have 1/2 times 8 times sine of the angle, which is 90. Okay, now we have, so now we have 1/4, 90 over 360 is 1/4 of, we have 8 squared, so 64 pi, minus we have 1/2 times 8 times sine of 90. Well, this sine of 90 is going to be 1, so when I do 0.5 times 8 times 8, when I do sine of 90, it's not really doing anything. So really, we get 32 for the area of the triangle. 64 divided by 4 is, 64 divided by 4 is 16. So this is 16 pi minus 32. We're going to put the 16 pi into the calculator. 16 pi into the calculator, and we're going to subtract 32. What we get is our answer, 18.27. I think they wanted nearest tenth again, so we're going to put that in as 18.3. Okay. Now we're back to sector again. So for this one, again, we got to be careful because they have, they've given us the diameter. So we got to know that the radius is 13. Otherwise, we end up with the wrong answer. So they try to trick us in two ways. The other way is, this is 120. The shaded part is then 60 because we have a semicircle again. All right, so that's the first thing they try to mess you up on. Then it's times pi r squared. Well, r is not 26. R is half of 26. So we have basically 1/6 of pi times 13 squared, which is 169 pi. This one they want to the nearest tenth, so we're going to type it all in. We have 1/6 times 169 times pi. So for this one, we have 88.48, which is going to round up to 88.5. All right, for the area of the shaded regions, that's the last two questions here. We take the shaded minus the unshaded. So looks like we have two squares. So we're going to do the big square minus the little square to get our answer. Well, the big square has side lengths of 5, so that's 5 times 5, base times height. The little square has side lengths of 3 and 3. So we have 25 minus 3 times 3 of 9, so we get 16 for our answer here. So that one was pretty easy because we didn't have decimals and we know how to get the area of a square really fast. Okay, the last one, number 17, is going to be the parallelogram minus the circle. Well, the parallelogram is still base times height. This one, we got to be careful. It says nearest whole number. So let's see what we have here. So we have 6 and 3 as these kind of pieces of the base. So we have a base of 9, really, when you add those together. And the height is 6. So we have the height of 6, 9 times 6. Minus for circles, we do pi r squared. Be careful again, this distance is 6, half of that is 3. So we have 54, 9 times 6, minus 9 pi. We're going to punch that in, and we will have our answer. So 54 minus 9 times pi. So it looks like that rounds to 25.7 to the nearest whole number. That's just 26. All right, feel free to rewatch anything there. I hope that helps. When you have 100% on this, email your teacher and they'll give you access to the retake.